Good morning. My name is Álvaro Márquez. I am a geologist from a university near Madrid in Spain, University Rey Juan Carlos. And today I'm going to talk about some aspect related with some existing scientific controversies in the Canary Island geosites, which we have studied in this project that we are presenting today. At first, I just want to introduce in my talk why this talk. In this project, we have made a study. In the first time, we made an inventory, a catalog of some geosites, which intends to cover the most relevant aspect of the geological history in the Canary Island. This project tried to become a strategic tool which made usable as a scientific but also as an educative resource to put in context and to strengthen the value of the very important geoheritage in the Canary Island. But specifically in this talk, I'm going to talk about the interplay between this scientific work about geoheritage and the scientific work that currently is made by several groups in Canary Island about geological processes. This is because if we see a definition of geoheritage, we can use this about a group of geological elements which show special interest, mostly scientific, but also educational or touristics. And this geoheritage includes all elements resulting from geological processes. I mean, your heritage is formed by geological elements, but those geological elements are talking about a story about the geological processes which form them. The geoheritage of an area is composed by several geosites. And a geosite is an area where one of several of those geological elements relevant due to their special value. But the geosites are places that are showing us unique processes. So as we can see here, it's a intimate interplay between geological elements and geological processes. In a geosite, we can see a geological element. We can see an outcrop, we can see landforms, we can see minerals or fossils, but the important is that those geological elements are talking about the geological processes which form them. However, in scientific research, the way between the data, in this case the geological elements that we can see in the fields, and we can study, and we can collect and go to the lab, and the geological elements that we can deduce from those geological elements, it's a multi-step processes. It's a multi-step processes between the observations and the understanding of the geological processes. to go for this route, we need to make some interpretations, because when we are studying geological processes, many times we are deducing processes that occur in the past. We cannot see the processes forming at present time the geological elements, but we need to deduce by the interpretation. That interpretation is based on scientific methods, is our scientific research. We, as geologists, try to go for that road between the observation of the geological elements and the understanding of the geological processes. In the heritage studies, we focus on geological elements, but we can't forget that those geological elements are talking about a story about the geological processes. However, this interpretation is not unique. And along the time, many times that interpretation changes, but because the geological knowledge increase and new hypotheses appear, but also because we make new observation and new and different observations. Many times in geology, observation are strongly related with what elements are we looking for. We see what we're looking for. And this is very important in order to understand the base of many of the scientific debates and the scientific controversies which we can see in present science. In the case of Canary Island and in the case of the geosites of Canary Island, we can see a lot of different geological processes which have shaped the present geology of the island. But in the case of Canary, probably one of the main processes of one of the most unique processes which we can study in the archipelago are the large flank collapses. It's those large flank collapses, large catastrophic and fast collapses producing debris, avalanche, which are many and very good examples in the Canary Island, as for example, El Golfo landslide, probably the youngest mega landslide in Canary Island that we can see in El Hierro Island. There are a lot of examples, a lot of geosites in Canary Island where we can see this kind of processes. But also there are several geosites in Canary Island which there are strong scientific controversies and scientific debates today about the story that we can see, that we can deduce in those geosites. I have selected 3 examples for this talk to try to show some of these controversies. First one is in La Palma Island, Cumbre Vieja volcano, and is related to the sound faults that appear in 1949 during one of the last eruptions in the island. It's, as we are going to see now, a scientific controversy which has been also produced a strong citizen debate, mainly related because of the role of media. After that, we are going to see another example in El Hierro Island, San Andreas landslide, and what is the possible activity of that large landslide today. And last one, which is for me probably one of the most important scientific debates to date in the geology of Canary Island, not only because of the strong implication for the geology of the Tenerife Island, but also for the role as an example to understand those kind of processes all around the world. And it's the scientific debates about the origin of Las Cañadas Caldera. Probably most of you or all of you in any moment have been related in any way with the story of a proposal of a mega transoceanic tsunami resulting from a future more or less probable lateral flank collapse of Cumbre Vieja volcano on La Palma. This proposal was strongly amplified by media, and as we can see in the left slides, is the result of a modeling about what could be the consequences of a large slide of the west flank of La Palma Cumbre Vieja volcano sliding to the ocean. But what is the origin of this model? Why the authors propose that model? Well, that is related to the occurrence in 1949 of some faulting on the western flank of Cumbre Vieja volcano at the same time that one of the last eruptions in the volcano. As we can see in the picture of the right side, when we can see here some men as a scale, at the same time that volcano was erupting, as we can see in the background, in the foreground we can see that some faults, some of them with some meters of slip, develop on the west flank of the volcano with a slip down, but also to the sea, all this system. The authors that proposed the tsunami model previously have been suggest that those faults could be a sign of a flank instability of the volcano related with the eruptive processes. So they suggest that in a future eruption of the volcano, some faulting similar to those could occur again, and even they could produce the slide of the flank of the volcano. However, many researchers have been interested in that eruption, and not all of them make the same interpretation about the nature of those topographic scarps which appear during the eruption. But some of them propose that those scarps are just the surface expression of the lateral intrusion of the dike, which from the central bend produce the lava flow of Llano del Banco of the north part of the fissure system. So even today the scarps are not so well exposed as in the picture that we have seen previously. They still are present, and they still can be observed in the field. So people who could be interested in this story about the tsunami, in this story about the possible instability of volcano flank during the eruption, can go to the field and can see these scarps, which are a very good opportunity to talk about this story in the field. The second example is this time in El Hierro Island, and it's related to an standing outcrop of a fault plain, which is called the San Andreas Fault. We can see here in the pictures the fault plain, and the main controversy probably related to this outcrop, or the story that we can talk in this outgroup, is if we are seeing there a unique example of an aborted landslide, old aborted landslide, or if we are seeing a potentially active landslide involving a large portion of the east flank of the island. There are several studies, several geological studies. We have mapped the area, and that amazing outcrop of a fault plain is not isolated, but is related to an entire fault system, which we can see here in this map and in this cross section. And several studies have proposed that the geomorphology and topography of the area suggest that maybe those fault systems are not only young, but maybe active. In addition, in the last years, there have been some measurements about the possible movement of this structure, specifically in the north part of the fault system, and even it's a very small displacement, less than 1 millimeter. Some of the published results suggest that the entire system could be creeping slowly but in an active way. If this is true, we can be observing in the field the trace, the faults related to a large slump area. Again, a potentially very interesting story to talk about the public, not only about the amazing geology that we can see in that outcrop of the fault plain, but also about the possible implication and the importance of study and monitoring of this kind of structures. And lastly is the case of one of the most amazing landforms in Canary Island, at least for me, which is Las Cañadas Caldera in the center of the Tenerife island. It's a large depression we can see in the picture of the top, with Teide stratovolcano, one of the most impressive also stratovolcanoes in the Atlantic Ocean, and UNESCO World Heritage Place, and a landform which is the location of a strong life during long time scientific debate about the origin of that structure. And as we can see here in the picture of the bottom, for example, in a recent paper last year in Earth Science Reviews about the volcanological controversy of Las Cañadas Caldera by Juan Martín. For me, as you can see in the title, Dr. Martí talks about a possible review or the end of a long volcanic controversy. For me, it's a review. The volcanic controversy, I think, is still live and probably is going to be still live for many years. The main controversy in Las Cañadas Caldera is the role of lateral collapse, or if is there any role of vertical collapse in their origin? Because all the authors agree that some lateral collapse occur in the thumb, which form the Icod Valley to the north. But some authors propose that the lateral collapse is so large that involves the entire Las Cañadas Caldera depression. I mean that the large wall that we can see today in Las Cañadas Caldera is the result of a large lateral collapse. However, other authors propose that the role of lateral collapse is only produced in the north flank of the volcano, and that the main wall of Las Cañadas Caldera that we can see today is the result of several vertical collapse related to caldera collapse processes during explosive eruption. The last one, the eruption that produced the so-called El Abrigo ignimbrite, that, as we can see in the pictures below, we can see that is related to a complex multi-event debris avalanche in the north of the volcano. It's a very amazing scientific controversy today, and there are a lot of geological elements that contribute to this story, and it's not easy to show just one of them in the field, but probably one of the places where we can talk about this story is in the geosite, where some phases of the El Abrigo eruption can be observed, mainly in the north part of the island. In some places, as we can see in the picture above, El Abrigo, the ignimbrite of El Abrigo is quite normal ignimbrite. However, in many places, El Abrigo ignimbrite is with a high content of lytics, as we can see below, and some of the characteristics of that breccia have made that some authors have proposed that in fact it's not a lithic-rich ignimbrite, but is the product of a lateral blast produced by the decompression of the hydrothermal stem of Las Cañadas volcano due to the large landslide to the north. It's not easy to show to the public the details of this story in the field, in the outcrop, but in any case, probably it's very interesting to talk about this scientific debate to the public in order to strengthen the importance of the geological observation and interpretations that we made during many years to try to understand what is the origin of those deposits and also what is the origin of that amazing landscape which is Las Cañadas Caldera. And in fact, in Las Cañadas Caldera National Park, in Teide National Park, when we go by the cable car near to the summit of the Teide, there is a cartoon that we are showing you here, explaining to the public what is the origin of that amazing wall that they are seeing in the foreground. However, unfortunately, in this kind of cartoons at the national park, only one of the explanation is shown at each time. There is no panel confronting both hypotheses and showing to the public that geology is a life science. Geologists are involved in strong scientific controversies. We are pushing the advance of the understanding processes with all the important implications for the natural resource, but also for natural hazards in the zone. So, as a conclusion with this talk, I just would like to show, to strengthen that the scientific controversies are an intrinsic part of scientific research. Many times, public don't understand why scientists don't know agree, why scientifics sometimes we show different interpretations, different opinions. And I think it's important to show the people, to show the public that this is not a flaw of scientific methods, but this is one of the most important things of scientific research. Specifically at Canary Island, there are several geosites that currently are related to relevant scientific controversies, which in my opinion could be shown to the public because it's a part of our heritage. The stories that geologists are deducing from those geological elements are also very important, not just the geological element, but mainly the geological stories, the geological processes that we are deducing. So in scientific controversy can be called, therefore, a powerful educational tool, a power tool for showing people what are the scientific aspects of geology, how is geology as a science, and in this way try to increase the interest of the general public, not just for our heritage as a part of our heritage that we must care, that we must protect, but also because it's part of our knowledge, our understanding of the earth, the world that we live. Thank you very much.